crypto?
Yeah, it was always a hot dumpster fire.
Always?
Yeah, I mean, I'm not going to say that it was all fraud. Some of it was a pyramid scheme.
Cryptocurrency surge that's been gripping Wall Street since President-elect Trump won the election last week.
As we reach the conclusion of our exploration into cryptoeconomics and blockchain incentive structures, let's distill the major concepts and findings from our journey, highlighting the evolution and future directions of this dynamic field. Blockchain fundamentals. Architecture. Blockchain's decentralized nature enhances security and transparency, relying on distributed ledgers, nodes, consensus algorithms, and cryptographic hashing. Consensus mechanisms, essential for transaction validation and network security, mechanisms like proof of work, a POW, and proof of stake, POS, each offer unique advantages and challenges. As we reach the conclusion of our exploration into cryptoeconomics and blockchain incentive structures, let's distill the major concepts and findings from our journey, highlighting the evolution and future directions of this dynamic field. Blockchain's decentralized nature enhances security and transparency, relying on distributed ledgers, nodes, consensus algorithms, and cryptographic hashing. Consensus mechanisms, essential for transaction validation and network security, mechanisms like proof of work, a POW, and proof of stake, POS, each offer unique advantages and challenges. Smart contracts and dApps, smart contracts automate agreements, and decentralized applications, dApps, expand blockchain's applications, minimizing reliance on intermediaries. Incentive. Types, financial rewards, reputational gains, and social motivations fuel participant engagement in blockchain networks. Incentive. Design. Effective structures, including rewards, penalties, and staking mechanisms, align participant actions with network goals, fostering security and growth. Tokenomics and economic models. Utility, security, and governance. Tokens each play specific roles, from providing service access to representing ownership and enabling decision-making. Token economy. Design, balancing token supply, demand, and use cases ensures long-term sustainability and aligns incentives within the ecosystem. Game theory and behavioral economics. Game theory, strategic interactions and incentives create cooperative dynamics, preventing malicious behavior. Behavioral economics, psychological factors influence participant engagement, guiding incentive designs that enhance user experiences. Security, regulation, and social impact. Security, incentives for security contributions, combined with penalties for malicious actions, help maintain network integrity. Regulation, legal frameworks influence incentive structures and ensure blockchain systems meet compliance standards. Social impact. Blockchain's potential for societal benefits includes financial inclusion, transparency, and supporting humanitarian efforts. Reflection on cryptoeconomics evolution, technological advancements. Ongoing advancements like Layer 2 scaling, cross-chain interoperability, and new cryptographic techniques enhance blockchain's scalability and usability. Matured incentive models. Evolving designs now better align participant motives with network goals, leveraging game theory, behavioral economics, and real-world insights. Expanding use cases. Applications continue to broaden across industries, from finance and supply chains to healthcare and governance, each with distinct challenges and incentives. Ethical and social considerations. With greater adoption, ethical issues such as environmental impact and equitable access have become priorities in fostering responsible innovation. Future directions for research and development. Advanced consensus mechanisms, scalability, and efficiency, developing hybrid or alternative consensus models like proof of space and time to meet network demands while minimizing environmental impact. Cross-chain interoperability. Interoperable networks, enhanced protocols for cross-chain communication, including atomic swaps and bridging technologies. Increase blockchain network utility and connectivity. Privacy. Enhancements. Privacy-focused solutions like ZK-SNARKs balance transparency and confidentiality, addressing privacy challenges. Security innovations, new cryptographic techniques, and multi-signature solutions strengthen blockchain security. Economic models and incentives. Behavioral economics. Deeper insights into user psychology, refine incentive structures, driving engagement, and network health. Tokenomics. Evolution. Research on emerging token models and governance mechanisms can optimize the structure of token economies. Social and ethical implications. Ethical applications. Responsible blockchain. Use cases can address societal issues from inequality to resource access. Regulatory adaptation. Understanding regulatory frameworks across regions can help blockchain projects navigate legal complexities. To further understand the transformative impact of blockchain, it's crucial to delve into specific mechanisms that drive its success. One of these is the consensus mechanism, a set of protocols that helps blockchain participants agree on the state of the ledger. Key types include proof of work, POW, and proof of stake, POS. In POW, computational power is used to solve cryptographic puzzles, making the process resource-intensive but secure. POS, on the other hand, is less energy demanding, as validators are chosen based on the quantity of tokens they hold, promoting a more sustainable system. Another essential element is Layer 2 solutions, which aim to enhance scalability and reduce transaction costs, a significant limitation for high-traffic blockchains like Ethereum. These solutions, such as rollups and sidechains, handle transactions off the main blockchain, allowing more transactions per second while maintaining security. With Layer 2 technologies, blockchain networks can overcome bottlenecks that currently limit broader adoption in sectors requiring high transaction speeds, such as gaming, social media, and finance. Furthermore, decentralized autonomous organizations, DAOs, are reshaping governance structures within blockchain ecosystems. These blockchain-based entities use governance tokens to empower token holders with decision-making abilities, allowing communities to steer project developments democratically. For example, DAOs enable stakeholders to vote on potential upgrades, partnerships, or fund allocations, driving collective ownership and accountability. This approach fosters transparency and engagement, as users and stakeholders have direct control over the project's direction and governance. Innovations such as ZK-SNARKs, a type of cryptographic proof that enhances privacy, are also pushing blockchain technology forward. By enabling private yet verifiable transactions, ZK-SNARKs maintain confidentiality without compromising the transparency that defines blockchain. This balance of privacy and openness is especially valuable in sectors like finance, where user confidentiality is paramount. In sum, cryptoeconomics and blockchain technology provide a foundation for future decentralized systems, aligning incentives with enhanced scalability, privacy, and accessibility. By incorporating secure, efficient, and community-driven approaches, blockchain is not just a technological trend, but a sustainable framework for global economic and social transformation. As the world embraces decentralized systems, blockchain technology and cryptoeconomics represent a shift towards greater user autonomy, transparency, and responsibility. By empowering individuals and communities to shape the digital economy, blockchain has the potential to drive impactful, inclusive, and sustainable change across industries, reshaping the global economy for a more equitable future.